So, foremost, I have to apologize. I was going to try to record every single bit of work I did on this, but yesterday I went to the library and worked for maybe 2 hours, and because it's a library, I can't really just be recording. So, I'll try to go over what I did, and yeah. Alright, so I think most of it is actually in state. Actually, you know what? Most of it has not been pulled. Oh, I should have checked whether I had. Alright, there we go. So, what's the big deal? One, yeah, I implemented a few more things. So previously we had core and state, now we have game loop, future, yeah. So let's start with looking through core. I think this is basically the same as it was before, except state has been taken out of core, as you can see, and put into state. I think that was new to you. I think other than that, core is identical. State, or mostly. So first of all, move some things into state. I think I moved the console message as well, right? So now, which doesn't make a whole lot of sense. It should be in like constants or something, but another namespace. But anyway, model, now state is here, and everyone refers to it from here. Prints the initial version of the app, prints all changes to the app. Here's where it gets very different, very different. I introduced the notion of a render loop, and this was after a few days of thinking about it, right? I mean, I didn't have time to actually work on it, but I thought about it on the train and stuff like that, So I said, the real issue is sometimes this app is actually doing things through time, like literally time is something that happens in this app. Time passes. And I've never actually written an app like that before. I mean, all the apps I've written have always been big ball of state, right? An event comes in, which is always something that a human being does, basically. So a human being clicked this button, or a human being edited this text field. Then we have new state, We have a new state of the app. That's how I usually structure things. I've never actually structured with the notion of time. And eventually I thought about it quite a bit, and I said, well, I guess then time is just another type of event. The passage of time is another type of event coming in. And it's different than like a game render loop in general. Because the concept of the game render loop is inputs are queued between frames, right? And every frame, the events are all fired, right? This isn't like that. Or basically, the frame, the render loop is the actual processing of the game. This is a bit different structure-wise. I mean, you'd never, in the thing I'm writing, the way I'm writing it, you would never actually enqueue. It's not that you rely on time to be the side effect or to be the render loop itself. It's more that that in the future you will get these little messages indicating the passage of time. So whenever the messages come in, maybe you take side effects or maybe you don't. It's up to you. So it's a bit of a different structure than I think is the general game render loop. In a game render loop, there's the render loop, and within the word render or whatever as a function, you just do everything. You process all the mouse events and keyboard events that have been queued up to that point, and then that's the new state of the world on the next render loop. This is a bit different. The only thing that really happens is you actually get a constant dispatch of messages saying, it's this time, now it's this time, now it's this time, now it's this time, and of course it's going up, right? I mean, yeah. So, let's sort of read through it a bit, It's actually been, I said it was yesterday, but that was a complete lie. It's actually like 4 days ago, that I went to the library and worked on this, so I've actually probably forgotten quite a bit about how it works, but, so I think I also separated the notion of the dispatcher from, no, I think that was the case before. But anyway, I've added at least 2 new functions, right? Previously, I think we only had start game. Now we have enqueue and render as as things that you can dispatch against as well. The dispatch function is largely the same. I think I reorganized this in some small way, but I don't remember what the big deal. Oh, I remember. I'll get to that. Okay, let's start from where should we start from? So dispatch. This is where it all starts, right? When you're doing something, like right now, there's only one dispatch, right, in the entire program. And it's right here in core, and that's this one right here. And it calls state dispatch right here. Passes this message, which is start game, right? So start game goes right here, and all start game does is it switches the state from whatever it was before to playing. Simple dispatcher, right? In queue, what does in queue do, right? We don't even have a guy calling it right now, but if you did call it, it looks in, it updates in state in the enqueued keyword, and it basically conjures onto the value in here the message, right? And then it sorts the message by their run after, which is evidently a key, right? That's going to be in enqueued, or that's going to be in the message that came in, right? This message will have a key called run after. And all other messages would too. And so these messages are going to be sorted by their run after date, which I'll let you in is going to be it's a long, or it's a Java number basically. Actually, there's no such thing as longs. It's a Java number that is, it's the number of milliseconds since the epoch. And so if you sort those, they're in the order that they should be fired in basically. And then you convert it back into a vector, which is probably I don't know if that's expensive or not, or what. Just who cares? Performance, right? Later. So this basically is enqueuing new things that you want to occur in the future. That's the purpose of this thing, is to enqueue new messages that you don't want to fire right now, but you do want to fire at some point in the future, right? I point out that you can also put in things, like you could put in enqueue a thing with a run after of nil, or with no run after, right? With a run after of nil, or with a run after of 0, right? Which I think would always put those messages at the front of the, after they're sorted, they would have put those messages at the very front of the vector, right? See what I'm saying? Okay, so that's how we enqueue future messages that we want to run, not now, but on the next animation frame, right? Which the messages themselves could be in the past, in the right now, or in the future. But yeah, all we're saying is we don't want to run it at this moment. We want to enqueue it to be run, basically, right? Render just takes, it just passes through because it's pretty big, right? So it just takes render state a message. So it takes the current state of the world plus the message. And so then what do we do? Okay, it takes the state, and like the state in here, which is the same state, right? It has an enqueued variable, right? And so I'm just pulling that out in a map comprehension, right? And I'm also on the message. I'm pulling out time, and I'm as message. That actually seems like a bug to me. I don't think the variable is called time. I think the variable is called run after. We'll look at that a little bit later. Okay. To dispatch new enqueued. So this is I think interesting, right? I don't think I'm making any use of this. I think that's why that's not really an error. Oh, no, I am. Or I get what it is. This is the render time, right? Sorry, it's not the run after. The run after is a map containing, basically, well, we'll look at it. I sort of introduced this in the wrong order, it looks like. But anyway, this thing has a thing called time, and enqueued has a thing called run after. And they're both new they're both milliseconds since epoch, right? Time is the current time as specified by the render message. In run after is the time that I want you, if we are beyond this time, the run after time, that is to say I'm a message whose run after time is less than the current time, then that means I should be fired now, So that's what this does right here, right? This says split width, and it runs on if the run after time of any of the enqueued messages is less than or equal to the current time, then put those in the to dispatch, right? Otherwise, put them in the new enqueued, right? So this is basically splitting right at the point where all the messages, because we sorted, right? So this is splitting at the point where all the messages to the left are messages that, I don't actually get why to dispatch and new enqueued are, I've noticed they return seeks, but you'd think it'd be smarter to say if enqueued is a vector, subvec this and subvec that, so that, or this is a subvec and that's a subvec, so that I'm, it's just more efficient, kind of. Anyway, whatever. The point is, these are the things that need to be dispatched, and this is the new value of new enqueued, because this is the stuff that's still, its run after value is greater than the current time, so we just leave it in there, or we haven't done anything yet, but we will leave it in here. So then finally what we do is we say, okay, let's do a reduce where we associate on the current state on the enqueued value, we put the vector of new enqueued, because whatever reason this doesn't return a vector, it returns a sequence, right? And over the to dispatch, we're seeking over the to dispatch with the reduce of this function, which takes the current state of the world, which is we modified it ever so slightly with the new enqueued, right? And then it takes out of the whole message. Actually, the only thing it's really interested in at this point is message in the enqueued message, right? A variable called MSG in the enqueued message. They're going to dispatch. Where's that? Where's dispatch? Oh, it's down here. Oh, so this is a bit of a trick, right? Closure requires that things that you refer to have to be declared before, defined, declared, whatever you want to call it, before you use them, right? So like this function is defined actually down here. The only way I can refer to it down here is to declare it ahead of time, right? So this is really, it's binding to the var, not to the actual value in that var after this is a bit wonky, right? But that's how you do it in Clojure. When you have something defined below you that you need to refer to above it, and then you need to forward declare it using this declare dispatch function. It's pretty rare that you actually end up doing this, but sometimes it makes sense. Like in this case, right, render is being referred to by this guy, right? And dispatcher is being referred to by this guy, right? So there is a logical order here. The problem is this guy needs to also refer to dispatch function, because he's ultimately what he's doing is he's saying, I'm taking the things that were enqueued and that now need to run, and I'm dispatching them as if they're just being run, right? Okay, so it's as if these messages that were enqueued to be run at a later point are now being run right now, just by a completely different person, okay, and yeah, so then all it's doing is it dispatches on the current state of the world, which it got from here, and with this message, which it got from the thing to be enqueued, right? And so that basically means that all these messages that were enqueued for the future, once we hit the point that they say they should be run at, then we start rendering them in the order that they were. Well, it's not necessarily true. In the order that their run after time specifies, right? Because run after, and there's ambiguity there. Like, what if you specify two things that have the exact same run after time, right? I don't know whether the sort here, I don't know how that behaves, right? Whether it will actually preserve order if you sort using values that where everybody has the same run after value, but we'll figure it out if it's an issue. I don't think there's any place in this program currently where that is an issue, but yeah, something to keep in mind. And so that's basically it. Basically, we have a system that lets you enqueue messages to be run in the future, which is pretty cool. And let's go look at future, because there's things I haven't explained here, or maybe it's game loop actually, I'm not sure. So future is a very simple one, right? This is how you actually enqueue things to run in the future, and so this guy calls into schedule, so let's look at him. This guy calls into schedule, so let's look at him first. So all schedule is doing is schedule is also calling state, right? It's saying dispatch. It's calling it in this form, action enqueue. So that's the thing this is the guy that actually puts a message to be enqueued into the future, right? Run after time. This is, you're saying I want to run after this point in time, right? And message is the actual message you want to be fired at that point, That's it. That's all there is to it. You probably don't call schedule directly, because schedule is sort of it's the absolute reference, or absolute time after which you want the message to be run, right? You probably want to say something like, most of the time, you want to say, I want to run 50 milliseconds in the future, or 300 milliseconds in the future. So use delay, right? Which, will take one of two arguments. Either A, it'll take one argument, which means basically delay, or it actually calls into this one, right? This calls into this one, and this calls into that. with one argument, it'll basically say a delay of 0, which basically means do not delay it at all. Just it's the current time plus 0, which means it'll be enqueued as soon as we have the next render. It'll be run as soon as we have the next render loop, but don't run it right now, basically. Sometimes that can be useful for reasons, specifically like CSS transitions, where you want to set the CSS transition property first, and then afterwards you want to actually make the transition, but the transition property needs to be set before you make the transition. You could do it this way, right? Maybe. It's not 100% reliable, that, but whatever. Because, like I say, you can't guarantee when the next render loop will come in. The render loop, okay, well, we haven't looked at that yet either, but the render loop is running on the request animation frame, right? And the request animation frame may or may not, run between any 2 points, and so the general way to call it is the message and then a delay, right? I should have called this delay instead of time, or I guess that's redundant. Anyway, this is the delay you're actually going to add to the current time. So what you do, you just get the current time, right? Which is, I don't know if that's expensive or not. I remember long in the past people were saying that calling JS/date was really expensive, but I don't know if that's still true. I assume it's possibly not, Anyway, all this does is basically saying call into schedule, take the message, and take the current time plus the offset time you specified, and that's the time that we actually want to absolutely run. So very simple namespace, right? Which is good, right? Final part is the game loop, right? And so this basically is this is the game loop right here. All it's doing is basically saying, I should stop using the word basically so often. All it's doing is saying, this is the on next frame handler, which is just okay. It's hard to speak live and not use filler words. I apologize. This is the on next frame. It's looking through here and saying, I'm going to keep looping, or I'm going to enqueue. I'm going to have function run. First I create a Google async animation delay object on that function, which is basically, which is the thing that is used to render on the next animation frame, and then I'm going to start it, right, so that it will actually run on it. I don't know why I have to do 2 steps here, but I think it's because you can get this thing, and you can also call other functions. I just always call start on it and then just discard it, right? I don't worry about it. But you could actually retain this, and then you could do things like stop the animation frame, right? So it's not going to run on the next animation frame, or fire it right now, regardless of whether we're on the animation frame or not, or whether the frame is fired at all, right? So this is allow you to keep a reference. And the same way that set timeout, which I only learned about this very recently, actually. Set timeout, you can cancel them right after you started them up. I didn't realize you could do that, until pretty recently. Anyway, and so in general, the way the render message works is it does this once with the and it's basically it's going to run itself at some point on the next frame, right? Which is just going to run itself again. It's going to keep running itself forever. As a side effect, it also does a state dispatch on the current time, right? So it's basically going to run on every single frame. It's going to create this little map, right? This action render time t, and the time t is something it gets in reality on the request animation frame. The argument that's passed in is, I think it's called like a high. It's basically supposedly a more specific timestamp than even the one you get from date, although it may just be as good as the one you get from date. I'm not really sure, but it's a measurement of it's the milliseconds since the epoch thing again, and so basically you're just firing this every single time. Remember, it was looking at time and comparing that to what's the language I looked at? Comparing it to run after, right? That's this, right? The time is the epoch time, and the the time right here is the epoch time passed in from the request animation frame, and similarly the run after is the epoch time that we created right here with an offset, or we created right here by just saying at some point in the future or past or whatever, right? Yeah, that's it. So basically, that's all the new parts. So it's basically the big deal is it's a game loop that understands the notion of time. And then we actually kickstart the whole thing, right? That by calling this once, right, we started the whole thing and it'll basically loop forever. Yeah, that's it. So, sorry. What was I getting at? So what this is now it's a game loop, right? We introduced, it's sort of a different way than the usual thing, right? Because it's still, I would say this is very much still an event-based system, right? Unlike a normal game loop where all the logic is in fact in the game loop and nothing is actually happening between the game loop, our system, it's an event-based system where even the passage of time is an event, right? And it's just another event. The system is always running whenever it's always the case that a message comes in, an event message, whatever you want to call it, right? Let's call it a message. A message comes in, the message is applied to the current state of the world, and now we have a new state of the world. Then another message comes in, the message is applied to the current state of the world, a new message comes in. We don't have a render loop in the way this program is structured. Instead, we have a state of the world, and then events come in every once in a while. It doesn't really make, to the world, it doesn't make any difference whether the events are occurring 1,000 every milliseconds or one every 1,000 years, It doesn't make any difference, right? It's just a state of the world, plus a message comes in. This is sort of introducing as events the notion of time, right? So the only events that are ever coming in that are time-based are these messages right here, action, render, time, t. And whenever that does happen, as you saw, we basically go into, that's one of the things we can handle. And when that happens, we basically look into our enqueued thing, which says, let's see if there are any messages that should have been fired by this point. If there are, then let's fire them right now, as a reduce, And then now we're at the point where we have all the messages that should have been fired, and we're done again. We're done event processing, although the event in this case was the passage of time, I think that's a bit interesting. First of all, just because it's probably a bit different than the way most game groups are written, but I'm used to the idea of a big app state and messages coming in, so I like to stick with that idea. The other really interesting thing, right, is it means that this thing actually is printable at all times, right? That is to say, even this thing, even the idea of enqueuing things in the future, of things occurring in the future, is a serializable idea, because these are just vectors in the these are just maps that are these are just messages in the enqueued vector, right? Which means this whole state of this app can be printed at any point in time. It could be serialized. You could open a second instance of this app, and you could set the state to the deserialized value, and it would resume from that exact point, right? It would be like if you could play an FPS, and at any point in time you could just freeze the FPS, right? And then walk away and come back, and everything would be fine. The game would resume from the exact moment you left at, right? Which I think is kind of cool, It's not really a requirement for this app, but I think it is a cool side effect, and I think it's interesting. Other than that, I think that's really it. It's mostly the introduction of the notion of time. So you might ask, why was I introduced to the notion of time? Well, because I'm looking at this game in the future, right? And there's I think I've looked at it with you, and there's these, there's the notion of a bubble hits another bubble, and if the two bubbles happen to be of the same type, that bubble pops, and then afterwards the other bubble pops, and then that causes other bubbles to pop, other bubbles. So that's one use of time, right? We could just sit there. I'm thinking I'm going to do the bubble popping, which is supposed to be it's not supposed to be that all bubbles pop instantly. It's that bubbles pop as the thing around, shortly after the thing around them pops. So 50 millisecond delay between each pops, between each bubble, between a bubble popping and its surrounding bubbles that are of the same type popping, right? And so that's a good use for time, right? Time understands the idea of a 50 millisecond delay, right? Similarly, there may be other places, but mostly it was the notion. It was the realization that video games really are dependent on understanding the notion of the passage of time, which is not something I've ever dealt with before. I've never dealt with. Let's actually think about the UI and time passing on it. In general, in a UI program for the web, you just if you need to pass time, you do it as a sort of side effect, but it's not a big part of the program, right? It'll be things like CSS transition animations, right, or CSS keyframe animations, which are time based, but they're sort of a fudging of time, And I think this is an interesting philosophy too, kind of sort of thing, because another issue here is right now it's a pure idea, right? This is correct, but if I were to do this the way I think I should probably be doing this, which is when you fire a bubble, that's probably going to be a keyframe animation, right? I'm going to set the keyframe styling on that event, and I'm going to let the keyframe run through, right? That's interesting because the keyframe should be, or the keyframe, although the whole point of like CSS, of CSS in general, is that CSS is declarative, right? It's a declarative syntax for style. That's really, to me, that's the main point of it, right? The interesting side effect there is the time is not really declarative, right? Because it doesn't specify when did this occur, when did this transition occur, you know? I mean, it's declarative in the sense that it's declared, but it's not declarative in the sense that you can serialize that. Like, for instance, if I had a keyframe that took the bubble from here to there, right? And with it, if it's just a linear thing, you could actually just use transitions. But in reality, these keyframes, like I'm looking at them, are actually going to have to, they're going to have to get the bubble close to where you click, but then they're actually going to have to sort of hook it at the end to put the bubble in the grid pattern that all the other bubbles are in, right? And so it actually would need a keyframe, I believe. It'll be more like a, you know, like a hook a bit, you know. Maybe even as much as a shepherd's hook, I don't know, if you want to make it obvious that the thing is sort of moving into, or basically a hook with a spiral at the end. If you want to make the obvious that the thing is aligning to the rest of the bubbles, you know, that the bubble that was shot is aligning to the rest of the bubbles. Anywho, the CSS transition stuff, or the CSS keyframes, is semi-declarative, right? Because it doesn't understand the notion, that there's no way to serialize, like, oh, I've only moved this far in an animation this long. There's no way to serialize the idea that I've only moved this far in that animation. You know, the CSS transition stuff doesn't have that saved anywhere. You know, that we've only moved 40% of 100%. When you set the CSS transition, right, and you say, okay, the pixels, the box was previously here and now it's there. You know. When you set the CSS transition, you may set the box here, and then you may set the box to 100 over here. When you serialize the app, it may have only moved 40, but logically, the app has already moved 100, right? It's just that it's really almost a delay in the notion of time in terms of transitions. In terms of keyframes, I'd have to think about it a bit more. But I think it's the same thing. I think ultimately, your thing is at the final state already. If you were to re-serialize from that point, your transition has already moved, or your keyframe has already moved to the point that it's going to end on, right? Although I don't know what that means for keyframes. I don't know what keyframes this applies to. It does apply to transitions. I haven't actually ever used keyframes, so I'm looking forward to that a bit. But the problem is, right now this is a pure idea, right? And, like, yeah, you could literally serialize the entire state of the app and resume it. But with the inclusion of CSS transitions or keyframes, now the app is sort of, basically if you serialize it, it'll always be at the final resting state of all those keyframes or transitions, let's say. You know, it won't be at the intermediate state that you may have actually serialized it at, which is a bit of a kludge, right? If you actually wanted to literally be able to serialize, like let's say an FPS, if you literally want to be able to serialize it, you'd have to basically have events for, like, you know, the bullet itself. You know, the bullet would have to enqueue an event every single frame, where not only does it process one event, but then it also ends up enqueuing another event into the queue. So the bullet says, I'm at position 0, and the next bullet would say, okay, and it enqueues a new frame when you run the render loop. Now the bullet says, okay, now bullet starts at position 0, saying I'm moving at 20 meters per second, you know. At second 1, you know, when the render loop fires, the bullet would say, okay, I'm now at position 20, given the amount of time that's passed between when I started and the current time. And, I'm going to enqueue another thing for the next frame, so I keep moving. It looks another second forward. Okay, I'm now at position 40, and I'm going to queue another of me, you know, for the next thing. And basically, that's the only way to actually be able to truly persist the entire state of the app at any point in time. So, in order to remain pure, you sort of have to rather than using like these sort of helpers like transitions and keyframes, you would have to sort of actually manage everything state-wise yourself. You couldn't rely on them because those things are declarative, but they're not necessarily serializable, and that you could the time is a side effect to them. It's not something they actually capture in the declaration. You know, what time are we currently at in terms of this animation being played, you know? or what completion are we currently at in terms of this animation being complete, you know? So I think that's a bit interesting philosophically at some level. Anywho, so that's the big change. I was going to actually just try, if I could, to get this thing to work, because it's interesting, you know. I just read about it yesterday. It's this DevTools thing, so I think we can just say line, or I forget actually how we started this. Boot REPL is I think what we did. Just make sure things still work. That's a bit weird. Why is it pulling a new CIDR? I mean, you know, I may have actually have a boot dev here. Let's not get stupid if we actually have CLJ. Oh yeah, we have a dev task. We should just be doing that. What's different about this? It pulled in a different nREPL version. That's interesting. I wonder why it did that. I don't know. Okay, so you should be able to go to localhost 3000 as soon as this thing compiles. Alright. Control. Oops, it's right there. Okay. Alright, so I think that's pretty much where we're at before. Looks fine, so there's the initial state, and then, yeah, message came in that says start game, and then here's the new state. Oh, there's one, I remember. There was actually a little bit more at the, bottom of core, I believe. Oops, not core, at the bottom of state. Right, so I actually changed it a bit basically because I don't want to get messages for every stupid render loop, right? I sort of rewrote this so that if it's render or if it's in queue, and only if in the event that we have a render, right, as the message, and in the event that there is nothing in the enqueued, right, then it just returns the original state, doesn't do anything. If that's not the case, I think it's doing the same thing now, which is basically saying I either recognize the message because I could process it enough, which is cool, or it's an unrecognized message because it returned nil. As you can see right here, right? I didn't know what to do with this, so I returned nil, and then we throw a warning. So everything's still the same except that, like, naturally, right? This thing's throwing right now is throwing 60 frames per second, right? 60 events per second. That would be annoying if it just logs all of them. It will log them when there is something in the enqueued, right? When there's something in the enqueued queue, it will log the message saying, you know, this came in, this came in, this came in. But if there's nothing in the enqueued queue, it doesn't put anything at all. I might in the future just say, if it's render at all, then don't do anything. Right? So render never generates events. But it's kind of nice to be able to see when render will generate an event. So I'll think about it. The other thing is, yeah, it could be a pretty easy optimization later on to basically make it so that the thing isn't actually doing the request animation frame when there is nothing in the event queue, right? And it does do it only, it does it once and only once when the first item is put in the event queue. Once the event queue is cleared, it doesn't do it again. Then when the event queue is non-empty again, it'll restart the whole thing once and only once until the thing is queued and cleared, you know, that kind of thing. Just to avoid actually having the request animation frame running all the time. Having said that, on my system, what are we looking at? Localhost 3000? Localhost 3000. I'm looking for it. I'm not seeing it. Should be the one that's using the most CPU, I assume. Yep, there you go. Build nation. Alright, I mean, it's the request animation frame loop is not exactly using that much resources, so I wouldn't worry about it too much. On my crappy laptop, it uses 9%, but yeah, on this desktop, it doesn't even use any, so practically. And because it's request animation, if you actually go off of it, it uses almost nothing, basically, you know. Because it's only running, I believe, once a second at that point. So, kind of interesting. Okay. Yeah, that's it. Okay. And what else? I was going to say something else. Oh yeah, we're going to try to add in this new thing I saw. Where is it? Was it? Did I close it? DevTools. There you go. Yeah. Okay, so let's just try adding this. Why do they do this? I don't get it. Like, it's annoying because you can't actually click it or just do what I'm doing right here and select it. You have to, like, whatever. I just found it a bit annoying. Talk about being picky, though. Alright. So build.boot. What we're interested in is, let's see, is this making any claim that this is going to work? And does it have a dependency on Linogen? I don't know. Okay, I don't know. Anyway, let's put it in here. DevTools. Right, to activate at some point you have to install from DevTools core namespace. Ideally run this as launched when you're at. Okay, sure. Let's go into DevTools core. Source, CLJS, HTML5 core. So, I don't know why I didn't do it here, but in general, actually, HIJK element. I actually do things in alphabetical order. And, so notice I'm just pulling in the game loop. I don't even care about pulling anything in particular from it, which is kind of ugly. I don't actually like that. We have G. I wish there was like a Emacs thing that just automatically sorted all these in the right order for me. I'm sure there is. I'm just saying I wish I knew it. I guess. Lamino PQRS. EFGS dev. So yeah, that's anyway. Something went wrong. Could not locate DevTools. Yeah, okay, that's because we haven't actually restarted with it yet. Okay, so let's see. DevTools install, evidently. That's all we do. In the same way that we enabled console print, let's also DevTools install. Sure. And we're definitely going to log something at the beginning anyway, so we're good. Root dev, alright. Basically, it's just supposed to provide kind of closure script data structures that look kind of like JavaScript. When you're printing out JavaScript objects, you can sort of like look around in them and all that stuff, which is nice, you know. We'll see. Turn on custom formatter. Oh wait, I also need to upgrade my Chrome evidently quite a bit. Well, at least it didn't crash, right? So that's fine. At some point in the future this may work, but I'm gonna need to update my Chrome, which I should be anyway. I shouldn't be on the but I'm not gonna make it. I'm not gonna do this in the video. Yeah, so never mind. I'll see if I get this working on my own, and then just next time I'll show it to you. It'll either work or not, and that'll be cool. But I didn't really read this far. But yeah, you need to enable custom formatters on 48, and I'm almost certain we're on like 46 or something. Yeah, 46. So I think they release every 6 weeks or so or something. So I don't know if it's a full version of every 6 weeks. I really don't remember what it is, but it's in the future. I should be in the future though. I'm a developer, you know. But I think I'm just on the current. Anyway, though, it's now included, so I don't need to read this anymore because I don't think there's. Well, I guess I'll leave it open. Yeah, I'll deal with this later. Anyway, that's it for. I just wanted to get you up to date on what I've done, and that's it. It's yeah. So now there's a game loop that is event based, and it sends messages about the passage of time, and it processes messages that should have been run by that point, in order actually, in the order that their run at time specifies.